Welcome to our
Talk.
presentation.
I'm Liam.
I'm Malik. This is our presentation on the perception of spiciness through pain. So let's start off by saying that spiciness is not a taste. We all know the five main tastes are salty, sweet, umami, sour, and bitter, and spice is not on there. And that's because these five main tastes are all detected on our taste buds, and we have certain receptors for each of those five tastes, but we don't have any for spice. So then how is spiciness perceived, Liam?
Well, I'm glad you asked, Malik. So spiciness is actually pain. There are chemicals in spicy food that irritate nociceptors, which are nerve endings in your
What
mouth.
are nociceptors?
Yeah, so they're
okay.
nerve endings, and they're actually connected to the larger trigeminal nerve.
Ooh.
And the trigeminal nerve has two different functions. There's the mechanical nociceptor side and the thermal nociceptor side.
Ooh.
And both of those get irritated by these chemicals. So that's why when you eat really spicy food, it sends a signal through the mechanical nociceptor and the thermal nociceptor, which is mechanical being, ow, that hurts, and the thermal being, oh, that's really hot.
Ooh, that's hot. Oh,
Exactly.
that makes
so
so
that's
much
why
sense.
spicy
Okay.
food, that's why it tastes almost like there's heat on spicy food. And nociceptors are actually present in parts outside of the mouth too, which is why if you are eating spicy food and you get it on your lips,
like your lips
Mhm.
or like even your nose or something,
burns
that.
like hell.
Oh,
So that's why.
that makes so much sense.
And one thing I want to clarify really quickly is kind of what we were just talking about is a certain kind of spice, and those are really common with like peppers and things like that, where your mouth really burns. But if you've also ever had, like mustard or wasabi, do you know what happens?
Where it like clears up your nose.
Yeah,
and it goes all
it
up
burns
there.
in your
Yeah,
nose,
yeah.
right? And the reason for that is because those are actually odorants, and those are binding to the olfactory epithelium. So it's slightly different. But what we're going to focus on mainly is the kind of spice that you feel on your mouth, which is the activation of nociceptors. And the most common way that you'll see that, especially in mammals, is capsaicin.
Capsaicin, that's fun to say.
Yeah, exactly. So it's a chemical that you'll see in spicy foods a lot. And mammals, especially evolutionarily, are really sensitive to it. So for example, in parrots, they can't detect capsaicin. So if you feed a really hot pepper to a parrot, they don't care. If you feed it to me, I'll freak out.
Right.
And that's because it's essentially just evolutionarily something that we've developed so that capsaicin irritates any tissue surrounding it where it comes in contact, because it sends a signal through the nociceptor as a pain signal to the brain. So it binds both to nociceptors and to its own receptor that's specialized for capsaicin called TRPV1, TRPV1, which I have right here in this photo. So it shows it binding to the receptor, and then that releases an action potential, which sends a signal all the way to the spinal cord here, which then gets sent to the brain and processes pain. However, and which is why you'll get that resulting like burning, stinging, itching sensation. That's the signal being sent up to the brain from these receptors. And one product of that action potential is that it will actually increase the amount of calcium ions in the cell. So you can see calcium ions being entered in this diagram. And what will happen is if you have too much spicy food, calcium will actually overload the mitochondria, and that causes mitochondrial dysfunction, which is bad. No, so that's one product of too much capsaicin. So the way that we measure how spicy something is on the Scoville scale. So the Scoville scale is shown right here. A bell pepper, which is not spicy, will be at 0, whereas a Carolina Reaper will be at something like 1.6 million on the Scoville scale. And the way that they measure that, because pain response is difficult to measure, they'll take capsaicin content and they'll see how much it can be diluted before the heat's no longer detectable. So if you have a Carolina Reaper, you can dilute that 1.6 million times until you can't taste it anymore.
But
so it's
this
really,
is
really hot.
specific for peppers and chilies. So
Exactly.
You wouldn't be able to
You couldn't
test
do this
mustard on the Scoville
because
scale, right?
mustard doesn't have capsaicin.
Right, okay.
So a habanero, but here's the thing, like it can vary a lot. So a habanero, which is like some pretty spicy pepper, can go all the way from 5,000 to 50,000, just depending on the breed. Whereas on a completely other spectrum, 2% capsaicin bear spray, which is what you do to fight off bears, is advertised at 3.3 million units.
Jeez.
And pure capsaicin, which I don't really think you can get your hands on legally, hits about 16 million on the Scoville scale.
Okay, hold on. So then why do we even like spicy food? Okay.
Good
Well,
question.
okay, so I've been doing some research on this, and I found out that there is some evidence that suggests that evolutionarily speaking, spicy food poses some benefits to humans in that it can lower blood pressure, it can increase salivation, which is important if you have a really starchy, bland diet,
Sounds good.
Exactly. And it can also battle symptoms of sickness, so if you have spicy food, sometimes it clears your sinuses.
Yeah, my
right?
grandma makes me drink ramen when I'm not
Yeah,
feeling
yeah,
well.
exactly.
I get it.
And some studies even suggest that it can act as a painkiller for aches and pains in other parts of your body if your mouth is on fire, which seems a little strange.
Break your leg, eat a habanero.
Yeah, but we've actually liked spicy food for a really, really long time. So all mammals, we were talking about how mammals can detect spicy food, right? Birds can't, but most mammals can.
True.
But we like it, and we've liked it for a really long time. The evidence of spices used in cooking go back 6,000 years when prehistoric pots were found with traces of mustard seeds. This is surprising, especially because mustard seeds pose practically no caloric value. It may be that we like spicy because of the few benefits described above, like a decrease in blood pressure and the possibility of alleviating some cold symptoms. But what's strange about that is that we are the only animals that like spicy food. Yeah, humans are the only ones that actually like it, which makes sense if you think, because we eat foods that are that are sweet, because sweet sends a message to us that it's probably good for us, and then we get the sugar and the fructose. But spice is usually something that's supposed to be not good for us,
So,
right? Like,
so if other animals don't like it, how come we like it, Malik?
so that's what's really interesting, is that there is this prospect of benign masochism. A study was conducted in which subjects were given increasingly pungent foods until they couldn't take the spice anymore. And the people said that the level of spice that they liked the most was the highest spice before they couldn't tolerate it. So this demonstrates that maybe there isn't really an evolutionary advantage. Maybe we're all just slightly masochistic.
Interesting thought. Okay, we'll leave it on that note.
Hope you guys enjoyed the presentation.
Thank you guys so much. Have a good one.